Okay, let's write the ionic and net ionic equations for the reaction between solid copper with silver nitrate solution to make solid silver and copper nitrate solution. Let's begin. So remember, the rules are to write an ionic equation, we split any ionic compounds that are aqueous, we split our strong big 7 acids, but everything else, we leave them alone. Let's begin. Copper. Copper is a solid here. It is not ionic. It is not a big 7 acid, so we leave it alone. Now, when I leave it alone, it's extremely important to leave it alone. Do not embellish it. This copper at the beginning was solid copper with no charge. Do not add a charge here. It stays copper by itself. We're going to take that solid copper and react it with silver nitrate. Silver nitrate is an ionic compound. We have a metal, silver, and a polyatomic ion, nitrate. It's ionic and it says aqueous. So we need to split it up into the plus ions and the minus ions. The minus ion that we have here is the polyatomic ion nitrate. That's an NO3 with a minus. The positive ion that we have here is silver with a plus charge, Ag plus in solution. Now, if you had a single silver nitrate, you would get 1 silver and you would get 1 nitrate. You have 2 silver nitrates, so you're going to get 2 Ag pluses and you're going to get 2 NO3 minuses. Now we've taken care of our silver nitrate. Let's go over to our products. Here we have 2 silver solids. Silver solid is not an ionic compound. It's not metal with a nonmetal. It's not a big 7 acid. So therefore, we simply leave it alone. Rewrite it. Don't embellish it. Just leave it the way it was. 2 Ag solids. Plus, our last product is copper 2 nitrate. We have a metal, copper, and a polyatomic ion, nitrate. It's ionic and it says aqueous. So we need to split it up into the positive ions and negative ions that we have. The positive ion in copper 2 nitrate is copper here with a 2 plus charge in solution. The nitrates that we have are the negative ions. So we have NO3 with a minus charge, and that is in solution. Now, a big mistake that often happens to students is they'll write down just 1 nitrate here, and then they look over on the other side and they notice there's 2 nitrates. If ever you see that, a mismatch in the number of things, 2 NO3s here, 1 NO3 here, you've made a mistake. So let's look. We have in copper nitrate 2 of our nitrate ions. So we really needed a 2 in that case. So what I've shown here in blue is considered the full ionic equation. It shows all of our reactants and all of our products in their dissociated or undissociated state. In order to get the net ionic equation, we need to find those spectator ions, the ones that didn't participate, the ones that are the same on the left and the right. Now watch carefully. My students are often tempted to see a copper on the left here and a copper on the right and cancel them out. Do not do that here. This copper is neutral. This copper has a 2 plus charge. Those are not the same. You cannot cancel them. They need to be the same elements, the same numbers, and the same charges to cancel. So copper is not a spectator, nor is silver. Here I have 2 silvers with a +1 charge, and here I have 2 silvers that are neutral. They do not cancel either. The only spectator we have are the nitrate ions. We have 2 NO3 minuses on the left, 2 NO3 minuses on the right. Those cancel out. And what's left over is the net ionic equation. Let me go ahead and rewrite it. We have copper as a solid reacting with 2 silver plus ions in solution. That forms 2 Ag plus solid atoms and a copper in the +2 state in solution. That all together is our net ionic equation, and we always want to go ahead and do a double check. Atoms and charge. 1 copper, 1 copper. 2 silvers, 2 silvers. We're good on the atoms. Overall, I have a neutral and 2 positives. That's a +2 on the left. I have a neutral and a +2 on the right. We're also balanced by charge. So there is the net ionic between copper and silver.